Hey guys, this is number 17 on your test study guide. We are looking at the momentum before and after a collision of a truck and a car. So the formula you're going to use for this is going to be your momentum formula, which is P equals mv, momentum equals mass times velocity. So first up we have the momentum before the collision occurs. So you're simply going to take the mass of each car and multiply it by the velocity that it's going. So for the truck, it's going 4,100 meters per second. It has a mass of 4,100, and it's going a positive 3.8 meters per second. When you multiply that out, you're going to get 15,580. So we're going to go ahead and copy that up into the chart. And then our units for momentum is kilograms times a meter per second. All right, so that's pretty easy. For the car, you've got a mass of 1,800, and our car's velocity is negative 12, and you are going to leave that negative in there as well. So that's going to equal a negative 21,600, and that's kilograms per meter per second as well. So then to total up, you're just going to add that column up. So in this instance, we're going to have a total of negative 6,020 kilograms times meter per second as our total momentum of both vehicles before the collision occurs. That negative in there for the car and the total is just simply telling us which way the momentum is going. Like if we're going to say the left is negative, the momentum would be heading left, right? So in order to find the momentum of each vehicle after, we need to know what the velocity is of the vehicles after. Once they collide, like if you're in a car wreck, your car's not going to continue going the speed you went before and after the collision occurs. So we're going to take the total momentum and use it to find our final velocity. And we're actually going to use the same formula we've been using, but we are going to modify it a little bit by adding our two masses together. Because it tells us that the car and truck entangle and move together after the collision, that means they're stuck together. They're going to be going the same velocity together. So we're going to take our total momentum and times it, and our momentum before the collision, and set it equal to our mass of the two vehicles times its final velocity. So it's still the same formula. So we're going to have negative 6,020, and that's going to equal our two masses together. And we're going to assume that these cars lost no mass in their collision, even though in reality, probably parts of it are going to fall off or get, destroyed in some other way. So 4,100 plus 1,800, and then times our final velocity. So you'll add those together, you'll divide, you're going to end up getting a final velocity of the vehicles of negative 1.02 meters per second. So that means these car and truck are stuck together, sliding to the left at 1.02 meters per second. That negative, again, is telling which direction you're going. So now you can take that final velocity, use it to find the individual momentums of each vehicle after the collision. So you're going to take, again, their mass and times it by the new velocity. So 4,100 times negative 1.02 and 1,800 times negative 1.02. All right, to find separately what their momentum would be. For your truck, that's going to be negative 4,182 kilogram meter per second, and then negative 1,836 kilograms meter per second for the car. And then you'll add up those again, you'll get negative 6,018. Now you'll notice that these numbers of your totals are very similar. They actually are supposed to be very similar because we're conserving the momentum. We're saying all your momentum is the same before and after. So because of rounding our numbers, like we rounded it to 1.02, that's throwing it off a little bit. So you're probably not going to get exactly the same number due to rounding throughout all of your calculations. But you should see numbers that are very close together. Like this is just 2 digits apart. So if you got something very different, then something went wrong with your calculations and you'll want to check it over. Because they should be very close together and they technically should be the same if your calculations were not rounded. So this is how you solve this. You're only technically using that momentum formula for everything. Just kind of got to remember the steps of what to do, especially the most common step that is forgotten during testing is finding this final velocity. That's where people get stuck the most because they'll be able to do the first column, not know what to do because they'll forget to solve for your final velocity and how to find that for your momentum after. So don't forget that. So I hope this video helps. Let me know if you guys have any questions.